Good morning. In today's class, we are going to see about type checking. The learning objective of the type checking is that to understand the semantic phase of the compiler. Since type checking is found to be one of the component in the semantic phase of the compiler, we are going to study in brief about the type checking. The topics involved in the type checking are the definition, the purpose, goal, and the types, the rules that are followed in the type checking. Then comes the concept called as type system, type expression, and type constructors, and the specification of a type checker, and the type checking for an expression, statements, and quotations. Type checking. Type checking is the process of verifying that each operation executed in a program follows the type systems of the language. This generally means that whenever you are providing the data type to a variable in your program, by making use of those variables, whether it follows the data types that has been initialized in your declaration part, whether those variables are following the given data type or not. Analyzing those processes are mainly processed by your type checking. The thing is that whenever those variables are not following the data types, then those errors can be cached by your type checker. So if you see the position of your type checker, in the phases of the compiler, you have your lexical, syntax, semantic, and intermediate. In that case, so it is between your syntax analyzer and your intermediate code generator, where your syntax analyzer output is found to be a parse tree, which is given as input to your semantic analyzer, where your type checking process takes place. Once if there is no error, then your entire sequence of output of your semantic analyzer is given as input to your intermediate code generator. So basically, your type checker falls in the phase of a semantic analyzer of your compiler. So this is the basic thing that involves in case of your type checking. So the purpose of the type is to define what a program should do. It also that means that if you are having a variable, if you have declared an integer a comma b, and if you are trying to add a plus b in such a way that a is found to be an integer and b is found to be some floating point, which is not possible. So such types of errors, basically the meaning of your entire sequence or right or wrong, is the data types are following the rules properly or not, is checked by your type checker. Second thing is that it guarantees whether your entire program is meaningful. For example, if you are declared a string, and if you are trying to add a string with a number, which is not possible. So such types, whether it checks whether your semantic analysis of the program works properly or not. The third thing is that to document a program intentions, which means that somewhere a programmer can give their comments in order to analyze what happens in the particular line. So those types should not come under your type checking. So if intonations are working out properly or not, such types of errors are also being handled by your type checker. Last thing is your hardware parts. If you see, means whenever the data type and its size is following properly, or is that it reserves the minimal amount of memory, or it also makes sure that appropriate machine instructions are followed properly or not. So such types of basic things, it is the main purpose of your type checker. So what and all belongs to your type checking, we see, means depending on the languages, the type checker can prevent the following things. Application of integer functions to floats. For example, an integer, if it is declared as an integer, the value should be given as int type. It should not be given in float type. So such types of type checking belong to this cadre. Second thing is that if a variable is not declared but it is used somewhere in your expression, so it throws some errors. So such type of checking is also comes under this cadre. Next thing is that you have created some functions but it does not return any value. So such types of errors. Then next thing is that if you have you have called out a function, but the function name is wrongly called during your function call path. So such types of errors is also being checked by your type checker. Then division by zero, as well as your array out of bounds, which means that when a buffer overflow occurs, then those types of errors are mainly handled, or these types of errors belongs under your type checking. So the goals of type checking, it mainly based upon what errors belongs to what errors. The goals of your type checking is that the first step here you have your x plus y. This x plus y, which means that both the values should be numeric value. If x is equal to a, which means that x data types value and a data type value should match it should be same. Next thing, that if you're having an expression, in case of your conditional statement, this expression, it should be in some boolean form. Next is that if you're having an a of I should be an integer, which it basically it always we will be declaring some values. So I value should be, the data type of I should be an integer. Next, if you're having a records, R should be a record type. Next, you have your some arguments must have its right types. For example, for some functions A, B, and C, those arguments should follow a right data type. And if you're having a pointer, P star, P must be a pointer. So these are the main goals of your type checking. It makes sure the programmer uses those data correctly or not. Next, the main rules of your type checking is your type synthesis and type inference. Synthesis, which means that if you are making use of two different expressions, if you are called out two different expressions, then the sub expressions that are formed from the basic expression should follow the rules that are involved in the basic expressions. For example, if you're having A and B, and those A and B is of a data type int, which means that the A plus B should always follow the data type int. Similarly, here you see means if E1 plus E2 are two expressions, which means that it should follow into the type of E1 as well as E2. This is called as your type synthesis, which means that it builds a type of an expression from the types of its sub-expressions. Next is type inference, which means that it determines the type of a construct from the way it is used. For example, if you see it means that it means that we are going to say this is always true in some cases. Hypothesis we have studied in our mathematical thing, which means that if this is true, this must be always true. Such type of conclusional statements are being handled by your type inference. For example, if you are having null of x, always it is pre-declared that null is a list. It belongs to a list, which means that null of x always comes under the list. So this is the basic rules that are involved in case of your type checking. There are two different rules. One is type synthesis. The sub expressions that are formed by an expression should always follow the data type. Next is type inference, which means that in certain cases, if your one case is true, the following upcoming cases, which depends on that particular case, should be always true. So these are the rules that are involved in case of your type checking. So you're entering a concept called as type systems. Type system, which means that it is the collection of rules for assigning the type expressions. What and all rules that has to be followed for a type expression in the various parts of the program. This is called as your type system. What things should be followed for that particular program, what and all rules that are applicable for that particular program are called as your type systems. This type systems basically is of two types. One is static type checking, one more is your dynamic type checking. Static type checking, which means that it always happens at the compile time of your program. The static type, for if you can if you are avoiding the static type checking, then a program is found to be very good, which means that during your compile time, it should not throw any type of errors, means then your program is it's partially good in some way. So the static type checking, it is divided into 4 different cadres. One is found to be your type check. For example, here you are having an operator, that is C plus D. But the thing is that C is found to be an array, but D is found to be an integer. So this is not possible. So this type of error should not occur in your program. Next is found to be a flow of control statement. Unnecessarily, you are not supposed to give any break statement while you are processing your flow of control statements. For example, here in this function is found to be right because your break statement is properly placed. But in case of this here, if you see, means it throws an error because there is no condition over it, but suddenly it enters into a break statement. So such types of errors should not occur in your program. Next, if you see, means it is a uniqueness check. Uniqueness check, which means that If you have declared a value to a variable like macro values or something, hash defines some macro values are being declared to a variable, then that value should not change throughout your program. So this maintaining such type of thing is called as uniqueness check. Next is found to be a name related check, which means that if you are having a function with some name, means that function, whenever you are calling that function, it should be called under that name, not in some other name. So such types of process is called as your static dynamic, that is a static type of checking. These things occurs during your compile time of your process. Your next thing is found to be your next type is found to be your dynamic type checking. This usually occurs at the runtime. After performing static type checking, if there is no errors in your program, your program enters into the output part. The output part, which means that whenever you are processing your output, it should be a valid, the input what you are giving for that particular output should be a valid one. It should not, because of that, it should not occur any error in your entire sequence of your output, such a way that you have declared x and y, but the x and y are declared in terms of integer, but you are trying to add two strings, which is not possible at all. So such types of errors has to be removed in case of your dynamic type checking. So always your thing, it should be strongly typed languages must be processed throughout the sequence. Type expression. Type expression is the language construct, which means that it can be a basic type or it can be a type name. Basic type, which means that the variables, how the variables are declared under what data type, is called as your basic type. The type name can be, for example, if you are here you have created a structure, your structure name is student S1, so this can also come under your type expression. So your type expression can be a basic type or it can be a type name. Next comes under your type constructors. A type constructors can be an array form. For example, the syntax for your array form is array of I comma t. The t implies that it is of a type integer. So this should be followed in this type of constructors. Next is your product. The product, which means that if you are having two different type expressions t1 and t2, then the Cartesian product of t1 and t2 should also map to that particular type expression. Next is found to be your record, which means that it is similar to your product, but the case is that you can access the components of the record. Different fields of the records can be accessed with a particular name, that is called as your record. This comes under your type constructors. Next is the pointers, which means that if you are using a type expression t, then it should follow the rule of the pointers. Last is found to be your function. The function, which means that if D is the domain, then R is the range, then it should be of the type expression D colon R. It should follow the type expression D colon R. So coming to your next topic, it is found to be your specifications of your type checker. The first is your specification of your simple type checker. For example, whenever you're processing with your program, you start with your declaration part. So the declaration part, for example, you can have your ID with your identifiers of any type. So the identifiers of type can be, it can be a character, it can be an integer, or it can be some other form. So this is your general specification of your simple type checker, where you can have your expressions with combinations of your numbers or identifiers or something else. For example, if I'm making use of count of array, this array of 30, this 30 should be an integer type. It should not fall under some other data type. So this is the basic thing of a specification of a simple type checker. So a grammar for the source language defines a sequence of declarations followed by a single expression. For example, here we have seen the count array of 30. This 30 should fall under a particular integer value, integer data type. Next comes your next concept, that is called as the type checking of expressions. So your type checking of expressions, it starts with the thing called as an expression can be an identifier. So whenever you are calling it out an identifier, it generates a symbol table with some data entries over there. Next is found to be your expression can be a literal, which means that it can be a character form. Next, your expression can be an integer. So E dot type is equal to an integer, or your expression can be a real type, that is E dot type is equal to real. This is your type checking of expressions general forms. Next is found to be E tends to E1 mod E2. That means if you are having two expressions, that is E1 and E2 of the type integer, that is E dot type is also found to be an integer, E1 dot type is also found to be an integer, and E2 dot type is also found to be integer, means then your answer for E dot type always results in an integer. If it is not resulting in an integer, then it will throw an error. Next comes under your E tends to E1 of E2, which means that it is some array type. Here it is of the form of an array in such a way that if E2 dot type is an integer and E1 dot type is of an array form, array of s comma t, such a way that this t, that is this t should be an integer form. Always this t should be an integer form that gives the value of your array elements. So then ultimately your E dot type will be the data type of your t, else it will throw an error. Next comes your pointer form, which means that if E1 dot type is a pointer, then E dot type belongs to that pointer value, that pointer t. This comes under your t, else it will throw an error. This is your type checking of your expressions. I hope you can get it. The thing is that if it is an identifier, it will create a symbol table with the lookup entry id dot entry. If it is a literal, your E dot type will be an literal. If it is an integer, your E dot type will be an integer. If it is a real, your E dot type will be an real. If it is you are performing certain mod operations, then if an E1 and E2 are found to be an integer, then your ultimate mod operation result should be an integer one. If you are making use of your array, the indexing value should be the indexing data type should be your E dot data type's answer. Next is if you are having some pointers over it, then your E dot type should be the value of your t. This is your general rule for type checking of expressions. The next concept what you are going to say is for type checking of statements, which means that certain conditions are true, it will your output seems to be void, else it will show one type error. For example, here you have a certain set of statements, that is s tends to id is equal to e. Here the thing is that if your id dot type is equal to your e dot type, then your s dot type will be void, else it will throw an error. Here if you see, means you are having your id which is equal to e. If both the types are equal, then s dot type answer will be void, else it will throw an error. Next, coming to your conditional statement. In case of your conditional statement, if your e dot type is found to be boolean, then the output of s dot type depends on the cadre that is present in the s1 dot type. If s1, it depends on s1 dot type. So always if e is found to be boolean and the condition is true, then the s dot type answer is found to be your s1 dot type, else it will throw an error. Next, in case of as like your if statement, for your do while statement, if e dot type is found to be boolean, then your output of s1 dot type is found to be in case of your s dot type if the condition is true, else it will throw an error. So these are the things that are found in case of your type checking of statements. Next is type checking for correlations. Correlations, which means that it is a type of implicit type conversions that are performed by a compiler. So these can be ultimately performed by your compiler. And another concept is called as explicit type conversion. That is usually those type of conversions usually performed by the programmer. So for example, the type checking for correlations are over here. You have e tends to num, which means that e dot type is found to be an integer. Or else if you are having of the form e tends to num dot m, which means that your e dot type is found to be an real. Or if you are having something like e tends to id, which we have already seen in the previous case, then this e dot type, it will create a symbol table where it performs some entry into that symbol table. Next is found to be your e tends to e1 operator sum e2, which means that if e1 dot type and e2 dot type is found to be integer, then e dot type is also an integer. Else, if e1 dot type is found to be float as well as e2 dot type is also found to be float, you are performing some operations with e1 and e2. Ultimately, your answer will be also a float of that particular, that e dot type will be also a floating one. Or else, if you are having certain other cases over here, that is, if e1 dot type is found to be real, here if you see in this line, you are having e1 dot type is real and e2 dot type is real, means then your output is also real. There is no issues over here. But you are having some other two case, which means that you are having e1 dot type is integer but e2 dot type is found to be real, which means that some implicit type conversions has to be performed, that is done by the compiler, which means that this int is ultimately converted to some real numbers where you have already studied in the phases of the compiler. So into real is performed, so ultimately your e dot type will be a real one. Similarly, if you are having e1 dot type is found to be real but e2 dot type is integer, means somewhere some conversions has to be performed, so this integer will be converted to real, so ultimately your e dot type will be a real one. So these are the statements that are involved in case of your quotients, that is type checking for quotients. From this we end the concept of your type checking, and now we enter into a new concept that is called as your declarations. Now the main objective of declaration is that we are going to learn how to write the semantic rules for the declarations. Starting with the declaration, in general it can be in procedures. So we are need to track the scope of a variable, next the need of your symbol table, and computing the address of your variables that follows the semantic rules related to the 3 address code. Finally, we will be processing with our type, width and offset. So these are the general things that are present within your declarations. Now we are going to see the semantic rules for your declarations. Initially, your offset value is set to 0. Whenever you are going to call identifiers, the identifiers, whenever it is called, your symbol table will be having your name, its type as well as its offset value. So initially, since your offset value is found to be 0, if you are calling an your identifier, then your offset value will be added with the width of that particular identifier. If your type is found to be an integer, then your t width value will be equal to 4, or if your type is found to be in real, then your t dot width will be equal to 8. Now, if you are having a type of some array values, so at each time your array, you will be having n number of elements in your array. So those elements are called out by its integers. That is, your length of the array will be called out with some integers. So each and every time that num will be multiplied with your with value. So this is the concept. This will be your actual t width of your t width of an array element. Since you have n elements in your array, so for each and every element your t1 dot width will be multiplied with that particular number in order to get the actual t dot width. This is the process that is actually happening in your array element. If you are having a pointer, then your t dot type will be a pointer and its width value is found to be 4. So this is the basic semantic rule for your declarations. So here, if you see, means you are having a declaration. Whenever you are creating whenever you are calling a new identifier, a symbol table will be created where all the details of that particular data will be stored in your symbol table, or it will be encountered within your symbol table. So this general concepts involves whenever a new variable is called, automatically all those data that are related to a particular variable will be stored in your symbol table. Thank you. So these are the general concepts that we are seeing in terms of your type checking and declarations. Based upon this, assignment will be given in Google Classroom. Please complete it before the due date.